Up until now, we've been talking about two-class classifiers, but fundamentally, LDA and other classifiers are not limited to that. You can build, in fact, a multi-class linear discriminant analysis, but you need to do a little bit more work. And I'm not going to go through all the details of it because it's a fairly simple generalization of what we've seen for the two-class classifier, but let me give you some intuition. Let's imagine I have three classes, the red class, the green class, and the blue class. And I have, again, two features, F1 and F2, or 1,024 features, whatever it is. Now, a single eigenvector in this space is not enough to separate two classes, three classes rather, right? So take this line right here, and it can separate the green and the red from the blue, or this line right here, and it can separate the green and the blue from the red, but not all three. And when you have multiple classes, what you estimate is not one eigenvector, but two of them that carve your space up into regions. So what I'm showing you here is one eigenvector here, one eigenvector here, and I've carved the space up. Now, the issue, of course, with multiclass is since you're not projecting onto a single dimension, you don't have that nice, convenient single threshold. You have to do classification back into this original or now a two-dimensional space because you have to know which quadrant you're in. So that just turns out to be a little bit fussier. But fundamentally, all you're going to do is take the two-class linear discriminant analysis and compute more than one eigenvector in order to carve your space up into multiple segments. Again, we've assumed linear separation. Notice that these eigenvectors correspond to linear subspaces in the original dimensional space. But fundamentally, there's no reason to believe that the data is going to be linearly separable. So what if I had a problem like this, where my one class sort of wrapped around the spiral, and my second class wrapped around the spiral like this, and there is a really nice separating surface here. In fact, I've drawn it in yellow, where if I say that anything on the one side of this yellow helix-like thing here is one class and anything on the inside is the other class, I have perfect separation. But think about trying to do LDA on this data. Where can I draw a line that separates the data? So if I draw this line and project everything here, I mix up red and blue. And take any line here, and there is no way of doing classification in this space. And the reason is not because the data is not separable, it's because the data is not linearly separable. And there is the underlying assumption that we've been making up until now, is whether it was least squares, logistic regression, linear discriminant analysis, and many, many other types of classifiers. The linear ones are really nice because they're easy to solve. They don't take a lot of effort. It's doing least squares, it's doing maximum likelihood estimation, it's computing an eigenvector, but it's fundamentally limited if your data is not well behaved. And now the question is, well, what do you do? What do you do when you have this type of data? You can give up, that's one option, or you can bring more machinery to bear. And that's what we're going to start to talk about in the next few sessions.